Okay, so let me assemble. Okay, Umi Jais. So hopefully you can see. Can you see that? Okay. Okay, so this from Umi. She said that every subtopic made me want to do more and more exercises and practices. So far, so good. So the blur part is range for long. Sometimes I get confused whether there is any restriction. Might get confused to determine the sketch for ellipse, hyperbolic, circle, but we will get better when, yeah. Okay. As I mentioned yesterday, the sketching on 2D is very important for you to sketch the surfaces afterward. So for those still, I mean, feel that unable to sketch better, so you need to do a lot of exercise. But again, if you still cannot understand from the material that you have, then please let me know so that I can teach you maybe. Okay, so the next response, which is from Mahdi. So that he fully understood is about finding domain range with constraint, and the confusing part, still confused, equation, is it equation expression with equating expression with equation of parabolic. I think the same as the Umi's comment. Okay, anything that you want to add instead of I'm just reading from your friend's comment? Any of you? So that by using the synchronize, so we have a two-way communication rather than asynchronous is one way, right? So this is a time for you to ask or give any comment. So 51 responded. How about the other? According to the list that I've got, I have about 61 students so far. So for the rest who still not responding, maybe you have an internet problem so that you cannot watch the movie. Are the student here so that I know your problem? Are the videos okay? Okay, let me choose one more response from Nivea. Is Nivea here? Are you listening?
Yes, doctor.
So this is yours. Finding out the domain range. Okay, everything has been explained clearly. Okay, so that sounds good. Okay, so I will read another response later, so that I just want to know whether most of you fully understand about the domain and range or not. Okay, so that is the this self-reflection about the domain and range, because I can read some of you say that you still do not know how to sketch the 3D, the surface. Of course you cannot, because I didn't teach you yet. Okay, so hopefully I can share with you something about sketching for the 3D graph today. Okay, so then I stop the sharing. So some of you still watching the video. So Aldi said, I'm in progress, doctor. So how about the rest? Because okay, even though you still unfinished watch the video that I shared with you, I think it's okay if I proceed, because the thing that I want to share with you today is I didn't say that nothing to do, but if you unfinished that one, it's okay. You can watch later. So what's your friend said? Clear for now. Okay, clear. One question. I've watched until video 8 only. Okay, Asif. Mama Asif, one question. What do you mean by that? One question? You want to ask question? Sorry if sometime I forgotten to read what you have
Trial version.
what you have wrote on the chat. So Mama Asif, are you listening? What you mean by one question? You want to ask a question? Is it?
Trial version.
Excuse me, doctor, I didn't write anything.
Oh, I see.
Trial version.
You didn't write, but here your name appear one question. So that's not you.
Trial version.
Okay, that's fine. Okay, so let me so now we focus on the slide 2. I mean chapter
Trial version.
part 2.
Trial.
So can you see the slide?
Yes.
Okay.
Yes.
Okay, so now we go to the sketching. We'll focus on sketching on the 3D I mean two variable function. So you can just read your own. The objective is just to plot the 3D graph. Okay, so okay, before I use this slide, I want to have a more general question for you. Okay, about sketching on the graph. So yesterday we have talked about the graph for two variable function. We have two variable function. Sorry, this is one single variable. So two variable function should be on 3D, right? Okay. About the orientation. So about the orientation, the common orientation, we have X here, Y, and followed by Z. Actually, you can also use a different orientation if you want to, but with the condition you have to label. Okay, so maybe you want to have Y here, and then you want to have X here, and this one Z. So for this, we understand that all the value along the axis here, they are all positive because you put Y, only Z and X. But sometimes it is a bit complicated for us to sketch something at the back, meaning that for Y negative, for X negative, and also for Z negative. For this orientation, so when we say that X negative should be down here, but for this one, Z negative, it should be over here. But sometimes it is quite complicated for us to sketch the negative or the something behind here. So you can bring forward by, let's say you have the value of Y negative. So maybe at -1. So then you can just put negative. So we know that this axis is belong to negative Y, but something at the back is positive Y. Okay, but with the condition that you label, which is you let me know. Okay, that's the way you want to explain to me using the labeling. Okay, so it is about the terminologies. So terminologies, sometimes when you read the material or the books, or in fact my notes as well, you will see the word of curve. Sometimes you can see the word of surface. So the word of curve mean the sketching on 2D, whether you have XY or Y X plane. So the common one is Y X plane, or maybe you have to draw something on Z X plane, also possible. As long as they are on 2D system. Okay, so this whatever curve that you sketch, for example, you have quadratic, or you have what else? You have something like this. Okay, so that is called as curve. So after this, when someone who are taking this subject and say about curve, so it is understood that we have the graph on 2D system. Okay, about the 3D system, for example, you have a bowl. So here you have a bowl. So that is a bowl. Okay, concave up. So that is a bowl. So we call this as surface. Something that you can touch. Okay, so there is something here. So that is a surface. Okay, so this is called open surface because your bowl is open. There is, let's say you have a bowl contains the noodle, so it is open. So you call this as a surface. But if you put the something to cover it, okay, to make sure that your noodle still hot, so you put something on it, so you have a closed surface. Okay, so that is about the terminologies that you will always see when you have or when you're reading or have any material about this subject. Okay, so here is the graph, the common graph for two variable function, which is called as surface. Okay, so here you can see the word domain, right? So we have talked about domain previously. Okay, I don't want to talk about domain at the moment, so we just leave this for a while. So now I want to explain to you how can we have the surface. Okay, so now look at here. Okay, so now I want you to sketch, to plot, okay? To plot a point, a single point. For example, I just choose any point at 1, 2, 3. point 1 to 3. Can you please sketch that on your paper? Okay, what can we understand here? Maybe you have forgotten how to sketch a point on the 3D. So this is the value at x, and this one is the value of y, and this one is the value of z. Okay, then you have the x-axis here, and this is y, and this is z. You've done? Okay, so maybe if you have done that, can you share your answer through the WhatsApp so that I can share on the slide, on the screen? So anyone, please snap and post in the name. Okay. So Nivea, just a second. Okay, let me copy first. Okay, so here x is 1. Okay, so then y is 2. So they are intersect here on the xy plane, and then we have z equal to 3, so you got that point over there. Okay, that is the way you can sketch the plot. Okay, plot a single point. Thank you for sharing with us. Okay, so I would say that if I'm using the dot where we have here on the slide, so let's say this one is 1 and this one is 2. So we have the point here. Okay, and then that is the sketching on 2D, x1, y2. So remember we have a domain before this. So the domain is the sketching on the xy plane, or you can say that 2D system. So this is one of the point on inside or lying inside the domain. Okay, and then after that we project that point onto the or along the z axis, so you got the point here. So that is only for one point. How about if you have a many point, you choose any point in the domain area. So when you project that point, so you can have the point over here in 3D. This one is on 2D, which is on XY plane, and then you project that and you have the point here. And then you can have you can choose any point and then you have the point over here. And then imagine if you have a very many point lying inside the domain, so they will give you infinitely many numbers, many points, and they are on the surface. So the combination of this one is actually the set of the z value, which is we call that as a range. So this is actually the range. Remember what is the range? Range is the set of the value of z. Okay, where you can get z from the domain that you have chosen, and they are inside the domain area. If there is no constraint about the domain, so meaning that you are free to choose any value on the xy plane. Understand? Guys, any question? You can interrupt. Don't worry, you can interrupt. Okay, so that is
Okay.
okay. So that is a surface. Okay, so this about the 3D system. Okay. So in the yesterday's attendance, I asked you one question about the coordinate planes, right? Is it the question?
Yes.
Okay, so coordinate planes is well, I can read from your answer. I can see that okay, most of you say yeah, your answer is correct. Yeah, that is correct. But majority says about XY plane only. Actually, you can have the okay. Where is the XY plane here? Can you show me using from this diagram? So where is the XY plane? Where is the area that we call that as a XY plane? So the answer is there actually.
The bottom one.
Yeah, the
One z
bottom.
one z equal to 0.
Yes, that's correct. Meaning down here. So this is called as a XY plane. Okay, or you can see right on the floor. Okay, if you imagine, so how can I explain that? Sometimes quite hard for me to explain because it's one in 3D. Okay, imagine now, this is just like a classroom. You are inside the classroom. Imagine we have a physical class. Okay, so when you are inside the classroom and you sit on the a chair, and there is a table as well. So and also you have your lecturers is in front of you. Okay, so here let's say you are in my class. So if I'm saying that this one is front, okay, this one just like a wall. Okay, where are you now? So I draw, this is your desk, and you are here. So that is 0. And you watching forward. So this is forward. So this is called front wall, and this is called side wall. Okay, so your whiteboard is here. So this is whiteboard, and your lecturer, which is me, are standing over there. Okay, so this is front wall, and this is you, and this is left wall, which there is a window, maybe, I don't know, window. Okay, so when you have 3D system, meaning that when you have xy plane, meaning that we call that xy plane because of the value z is always 0. So this one is just like floor, okay, or bottom. Okay, so this one is called as xy plane. Why we call that as a xy plane? Because all the point lying on this area, the z is always 0. Okay, so instead of we call that as a xy plane, you can say that we have z0 plane, just a name. So let's say in exam I am asking you to say that to sketch a closed and bounded surface. Okay, closed surface. So sketch a cylinder. So I should give you an equation about the cylinder, which is bounded by xy plane, then you should understand what xy plane mean. Or maybe I said that bounded by z equal to 0 plane. So you have to have an idea where is the z0 plane. Okay, so that is the idea that I can share with you. So z0 plane is just like a basement or a floor. Okay, that is for xy plane where z is always 0. Okay, now let's see here the front wall where there is a whiteboard. So this is called okay, now this one is x axis. So this wall is always lying when x equal to 0. So that's why we call that as x0 plane, or we just call that as a yz plane because there is no x always 0. Okay, so meaning that all the point lying on this wall, all the x are 0. I mean the point contains the x equal to 0. Okay, so this is called x0 plane or yz plane. Okay, now your left wall or side wall here. So since this one is y, so this wall always lying when y equal to 0. So that's why we call this as y0 plane, where all the point on this wall, the y always equal to 0. Okay, so maybe you have the point of if you have a point P on that wall, this one, so your x may be 1, your y is always 0, and z maybe you have some number, maybe 10 and so on. Okay, so actually if you look at the scale, so maybe you might wonder, is it only on this area which is you have for example you have x0 plane here. So is it all the point, is it inside this shaded area? No, actually you can extend. It is very large and you can actually extend this one to have a z negative down here. Okay, as long as x is always equal to 0, and also you can extend the y to be the negative area. They are all x equal to 0. Okay, any question so far about the coordinate planes?
Clear.
Okay, so meaning that as a conclusion, when I'm saying that sketch the coordinate planes, so it is understood that you have to sketch, you have the floor, the front wall, and the left and the side wall. So that is called coordinate planes. Unless they say that sketch the graph for coordinate planes, for example, z equal to 0. So you know you have to sketch only z equal to 0, which is the floor. Okay, so that is about coordinate planes. And before I proceed on the sketching, maybe you have forgotten and maybe you have no idea what it means by octant. Okay, octant. Actually, octant is the continuation or extension from quadrant. You know what is quadrant? Quadrant is when you have a circle or not circle, but maybe on 2D, yx. So this is called the first quadrant, meaning that y and x positive. Okay, so when you extend it into 3D, when you have y positive, x positive, and meaning that z also positive, so that is called first octant. Okay, octant means number 8, right? Quadrant is 4. So meaning that quadrant is for 2D, octant is for 3D. Okay, so first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So when you extend that, this one is for, you have 4 parts here, right? Then when you have 3D, so it's become double, so becomes 4, it becomes 8. So that's why we call that octant. Okay, so the most favorite term that always been used in question is they will say that sketch the, for example, sketch the circle which is lying on the first octant. So it is understood that your sketching must be contains the XYZ positive. Okay, so that is just introduction about the terms. Okay, now we go to the sketching on the surfaces. So because there are so many surfaces out there, and some of them are easy to be sketched by hand, and most of the time we have a very complicated surfaces that it is impossible for us to sketch by hand. So meaning that the scope, the topic that the surface that we want to sketch by hand is just a very simple surface, but maybe we just modify from positive, then you have to sketch negative. Okay, but then the sketching is not, we are not using a complicated equation. Okay, because of there are very many surfaces, so we try to simplify by divide them into types. Okay, so as you can see there, we have a plane surfaces, and 2, 3, 4. This is about something curvy. Curvy, how to spell curvy? Curvy surfaces. Okay, plane, something flat, or we call that as a simple word. This is called flat surface. Okay, flat or plane surface, and the rest they are called curvy surfaces. Okay, so obviously the simplest one is plane, very simple thing that can be sketched by hand, and for the rest it is something more complicated, but you don't need to worry, even though I'm saying it is complicated, but it's still possible to be sketched with the condition that you follow the step. Okay, you have to follow the step, otherwise you might lose. Okay, so this is too wordy, right? So I don't want to explain word by word, so I will explain to the example. Okay, so about the types of surfaces, just now we divide into two parts, plane and curvy. So we start with the plane surfaces, and this one is in general. Okay, now we look at more details. Okay, so by looking at all this equation, can you see what is the special of this equation? What is the property of the equation? Linear, non-linear, or what?
Linear.
Yes, they are all linear equation. So this, we are talking about plane or flat. Okay, why we have plane surface or why we have flat surface? Because of they are linear equation. They are all linear equation. How can you determine whether the equation linear or non-linear? How can you know that? How can you justify that the equation that you have is linear or non-linear? No power. No power, yes. Meaning that the power, for example, for x here, the highest order is 1 or power is 1. They are all order 1. But if you have x square, so it's become non-linear. Okay, or maybe you have equation, trigonometric equation, right? So they are also, that particular equation also non-linear. So here we have, they are all linear equation. Okay, but between them, you can see I sort them into categories, right? But can you spot why I put them into category? So what is the property of each of them? Amount of unknown? You mean variable? Yes. This is about the variable. If you can see the first one, the total variable is 1. Okay, just x, y, z equal to the value. And the second one, the total number is, I'm talking about total number. We are still discussing on two variable function. Okay, so all the function that we're discussing in this course is more than one variable. So they are always two variable function. Okay, meaning that z is always a function in terms of xy. Okay, so even though you talk about two variable, so it is possible to have only one variable here. Okay, because our idea is now we want to sketch this particular graph, so the graph should be surface, something that you can touch. So if you've forgotten about our scope, so you might say that this one is a line, which is x0 is y-axis, right? And y0 is x-axis. So it is a line. Yes, that is a line if you're talking about if you're talking about 2D system. But now we are talking about 3D system. So they are all surfaces. Hopefully you're not confused with the thing. Actually, you are right. This one, they are all lines. These are also lines. But now we are talking about two variable function. So the graph should be in 3D. So when we talk about 3D, so it is something, graph which is a surface that you can, I would say surface is something we can touch. So curve you cannot touch. You can just draw on the paper, on the board, and so on. Okay. Okay, now the second one, you see the total variable. So we have x and y here, or we have y and z, and then we have z and x. So the total variable for this is 2. And the third one here, the total variable is 3. So why I'm trying to separate them? Because the process or the step to get or to sketch their graph is not the same. Okay, not exactly the same. It just maybe extra step need to be done first. So that's why I'm trying to separate them. Okay, so we start with the simplest one. So the simplest one should be total variable is 1. Okay, but the first three here we have done just now. So the first three here is x0, y0, z0. What are they? Okay, so yeah, some of you, one of you, sorry, I didn't get siapa yang tulis today, who wrote that. X0 means YZ plane. This is YZ plane, which is they are all coordinate planes. So these are all coordinate planes, which are the floor, the front wall, and the side wall. But just now I saw one of you wrote it is origin. Okay, again, you have to back to the aim. Now we are talking about plane. So is it origin is a plane? What is origin mean? Origin is a point. Okay, so yes, origin is lying in the plane of x0, y0, z0. It is part of a point. So when you answer that, when you're answering me, x0, y0, z0 is an origin, so it is not correct. Okay, it's not correct. I mean, not so accurate, because origin is part of, okay, because it is a point. But now we are talking about the graph in 3D. So the graph in 3D should be surface. So the correct answer is this is called, x0 is coordinate planes, y0 is coordinate plane, and z0 is coordinate plane. Okay. Okay, so now since you know that z0 is a base, is a floor, okay, the surface right on the floor, how about z equal to 5? Can you sketch for me z equal to 5 on 3D? Not z, I have to say z equal to 5, yes, it is a line. When you're talking about 2D, yes, it is a line. Okay, on 2D. Whether you want to plot zx plane or zy plane, so this z equal to 5 is a line. But now we want to sketch on 3D. Okay, I give some times for you to sketch. Maybe 1 minute. And post your answer in the WhatsApp group. Level 5. Floor same as XY plane. Okay, sketch it. Just a second. Okay, so ni siapa ni? Alif ni siapa? Alif is Arif Alif ni Alif lah ya? Okay, betul tak? Senyap je. Macam saya cakap seorang-seorang. Ni siapa punya kerja? Siapa punya kerja?
Saya punya.
Saya tu siapa? Sorry sebab
Alif,
saya.
Alif.
Alif Okay, Alif. So this is from Alif. Okay. Any comment? Is it correct or not? Betul. Okay. That's good.
I think it's correct.
That is correct. Yes. Okay, so that is for Z equal to 5. Now, I want you to sketch Y equal to minus 1. Can you sketch for me now? Y equal to minus 1. So let's say you are using a standard orientation. You can change your orientation if you want to. Still struggling? Okay. Okay, again, Alif. Okay, Alif is sharing. So maybe all of you can watch the Alif again. Yes. But yang lain senyap je. I post that first. Okay, so any one of you want to say something? Is it correct? Yang lain nak sketch three variable. Ya, betul.
Paling betul lah ni doktor.
Betul. Is that correct? Okay, so you have y equal to -1. So where is y -1? So this looks like this looks like x minus 1. Betul tak Alif? Betul ke salah jawapan awak? Ataupun yang lain?
Ya, asal aku tak boleh nak ni unmute ni.
Salah doktor ni. Ni. Ya Allah Alif.
Lish.
Wrong axis, yes. You can just change. This one becomes y. If you put this x becomes y, then your answer is correct. Yes. Mahdi share. Understand Alif?
Mahdi correct.
I thought
Mahdi.
x -1.
Oh, okay. It's okay. You can just erase x and you put y. And then this one becomes x. So that is right. But if you just leave like this, so the answer definitely wrong. So we have the answer from Mahdi. So this is from Mahdi. So this one x. So this is -1, which is belongs to y-axis. So this is the plane. Okay, everyone understand? Okay, for one variable, it's okay to be done just you convert from your imagination and you convert on the paper. But for two variable function and three variable function, so it is not so possible directly. You can transform from your idea, from your head, from your mind on the paper. You have to do some step. Okay, so now we move to more complicated. So we have two variable function. Okay, so for two variable function, let's say we start with the y equal to -x plus 6. Okay. So this one you need the step. If I'm asking you right now, can you imagine what is the plane looks like? Okay, maybe I've forgotten to tell you about what is different between plane and curvy. Okay, so plane means that something straight like this. So this is called plane. The paper here is called plane, which is flat. And this is also called, if I try to put some slope here, so this is still a plane, a flat plane, but there is a slope. Okay, but this one's flat, right? No slope. Or this one is infinity. The slope is infinity, right? Okay, so this one meaning that all this, because there is a slope, for example, y equal to -x plus 6, this is a linear equation, so the slope is -1. So meaning that it depends on the equation, or it depends on the line on 2D on y-x plane. So that is called trace. So what I want to say here, when you want to sketch 3D, what you need first is a trace or some traces. Okay, what is trace? So what are traces? Traces is your sketching on 2D. So after you have the sketching on 2D, then you convert or transform into 3D. Then you have the surface. Okay, so based on the example that I give you, I forgot the equation just now. What we have? Okay, we have y equal to -x plus 6. Okay, so now since your total variable is 2, then you need a traces. So you need a trace. a trace is a single trace on 2D. When you have 2D system, you can have whether y-x plane, or you can have whether z-x plane, or you can have whether zy plane. zy plane. So which one that you have to have here? So it depends on the variable that you have from the equation given. So from the equation given, you have y and x. So which one is the most appropriate one that you have to use here? The 2D one, the 2D system.
XY.
Yes, xy. So this is not possible because there is no z there. So your sketching on 2D should be on y-x plane. So what is the graph looks like? So now we are talking about trace. So when we have trace, it should be a curve, not a surface, a curve. Okay. So what is the graph of y equal to negative x plus 6? It's a straight line, right? Straight line. And there is a slope, negative slope, and interception at y is 6. So we have that one. Okay, so here we are not drawing, we are sketching. So meaning that you don't need to put some specific scale here. As long as you provide the correct intersection, so that is of course correct. Okay, so you don't need to, put the value here 1, 2, 3. Maybe for circle you need that, especially for circle shifted somewhere. But for this particular sketching, we don't need this one. Just sketch. Okay, so the intersection at y, we got 6 here. How about the intersection at x-axis? How can we get that value? Okay, Mama Aidil, you said that at x-axis is 6. Is that what you mean? Okay, Patricia said we have to set y equal to 0. Okay, so how can we get that as a 6? You have to set y equal to 0. Because why we put y equal to 0? Because this point is happens at y equal to 0, right? So that's why we assume when y equal to 0 and we got x equal to 6. So then that is your trace. Only single trace. But I'm so stressed on the number of traces because on the other kind of equation, especially for 3, total variable is 3, you have to provide more than 1 traces. So for this one, for 2 variable function, when total variable is 2, so we have only single trace. Okay, so now you can, after that, the second step, now you can convert to 3D. Okay, so before I proceed to sketch on the 3D, I want to ask you, what kind of orientation that you want to use? The regular one, or you want to change the orientation based on your trace here? Okay, tell me. I'll follow you. You have to decide. Based on trace. Okay. Change the orientation. Okay, so what I can understand from your answer that you want to use as in the trace here where you have y there and then you have x, and this one of course z. Okay, so now you sketch the green line, this green line again on the 3D. Just a line and put the same intersection value. Okay, since you are using the same orientation where you put the y and the x here, so same as in 3D, you put y and x here, so this one supposedly z, so your graph should be, I should use the same color, they are parallel, okay, and this one is 6 and this one is 6, so that is your step. Okay, sketch the same line as you done in trace, in your trace. Okay, so next, there is still a line. You need to provide a plane or a surface. So how can you provide the surface? You have to do the projection. You have to do the projection. You have to project the line that you have. So in which direction? Okay, so before we proceed with the projection process, I have a quick question here. Okay, from your trace, what is the variable missing? You should have 3 variable, right? So what variable missing? Z. Okay, so there is no Z here, meaning that if you can say that Z missing. So it is actually you are looking from Z. You are looking from Z means you are sitting here, and in your mind now, in your vision now, you can see this one from Z here. Okay, what I mean is, let's say I have this something. This is called, I'm not sure you can see that. So this is called just like a cylinder. This is cylinder. But if you look this one from your side, okay, that one, you can see the only just like quadratic, right? You agree with me?
Right.
Yes, it is a quadratic, which is 2D, U shape. So this is called, meaning that just like you are sitting in front here, okay, in front here, so that is your Z, okay, along the Z. So when you see from your side, that is from Z. So same goes as here. When you're sitting from Z here, so you can just see this one. Okay, can you follow me? You understand what I mean? Okay, maybe still blur.
Yes.
It's okay. It's okay. So now, since you are watching from Z, where you can see only this from Z, and this is you. You can see this kind of line. So in order for you to provide the surface, you have to do the projection, which means that in order to get the projection, you have to assume in front of you, this is you, in front of you, there is another y-x plane that you create, you assume, you imagine. So in front of you, there is a new y and x, and you draw the similar line which is parallel to your first sketching just now. So you draw the green line again. So you have to use a ruler so that your sketching is more accurate. And they should be parallel each other. Okay? And you have the 6, and here also the 6. Okay? So actually, if you are asking me, so which because you have Z here, so maybe some of you sketch the Z is very, very long. It doesn't matter, you can just put any line, I mean, on the, for you to assume Y and X, you can put any, you can choose any point from 0 to Z, from the Z0, this is Z, right? From Z0 to your location. So you can also put that behind here, and you draw a similar, you assume there is a new Y and X. And also you can put very many Y and X if you want to, but you don't need to waste your time. Actually, one is enough. Just I want to explain to you. So you can draw a very many lines as long as they are parallel each other. Okay. So from that lines, that is your imagination. Okay, so from that lines, so you can complete, you can just now it looks like you can have something like surface, right? But you have to complete to make it as a surface. So you have to draw a projection line. Projection line. Okay. So what is a projection line? Projection line is a straight line which is parallel to the z-axis. Because you are looking or watching from z, so that projection line should be parallel to z-axis. So just to have the surface, so you just draw the line here and the line here, and that line is parallel to z. Now you can have the surface. That is the surface. So this is called projection. The whole process is called projection. Okay, I repeat. In order for you to have a projection, so first you have to imagine in front of you, because you are sitting over here. So in front of you there is a new y-axis plane. Okay, so it actually just enough for you to provide just one y-axis plane, but this one I just want to explain to you. So do you have any question? Maybe I'm sure that you still blur, but it's okay. You just use the same example and you resketch again, and using your own version, and you compare. I'm saying own version mean you redraw yourself, but still based on the step that I ask. You have to follow the step. If you provide your own step, so I'm sure that easy for you to get lost and you cannot draw very well. We will do practice to understand further. Yes. Okay, so from the notes there are many example. So it's okay, you can do yourself first. It is 4, right? It's already 4. So maybe you can try to look at the second one. This one. 2y equal to 4z plus 5 and z plus x equal to 4. Okay, so you can try to re-sketch from the first example. Re-sketch that first. Okay. Okay, so before we dismiss, I give you some things later, where the due is tomorrow before 12 p.m. Okay, and that is another attendance. Sorry, I have to force you to follow my lecture. Okay, so otherwise you just lost. Is it okay? So I will send the attendance after this. Okay, so I think that's all for today. So I will share this recording lecture after this. Okay, so thank you very much.
Thank you, Doctor.
Welcome. Tak ada. Nak tanya soalan ke?
Saya nak tanya soalan boleh?
Boleh.
Pasal one variable tu.
Yang mana?
Yang tadi yang doktor bagi contoh y equals to negative 1 tu. Yang aksis negatif y yang doktor tunjuk contoh tu. Aksis tu kita boleh letak dekat mana-mana je ke? Atau memang kena selari dengan y punya aksis?
Okay, kejap. Saya...
Sorry doktor baru nak tanya.
Tak apa. Dia macam ni. Tadi okay, y minus y. Okay, tadi kalau awak gunakan orientation yang biasa, so because kalau yang version ni kan semua positif kan, so you kena tambahkan lah kat belakang supaya ada negatif 1. Okay.
Doktor, jadi yang tadi contoh yang Alif tunjuk tu yang dia letak dekat situ.
Dia buat kat belakang. Dia buat kat sini.
Kalau yang tu X negatif 1 lah kan?
Betul. Cuma saya kata tadi, sebab saya tak boleh nak cunting atas tu tadi. Dia boleh jadi betul. This one is correct. With the condition that this one becomes Y and this one becomes X. So betul lah. Kalau macam tu.
Maksudnya tadi kalau dia tukar axis tu betul lah.
Ya, itu yang saya sebut tadi kalau dia tukar. Tapi kalau you nak ikut yang macam Mahdi tu jawapannya, which is digunakan orientation yang asal lah. Yang asal maknanya bukan ni. So dia jadi kat tepi ni lah sebab ya kan, kalau awak lukis dia punya trace, sebenarnya ada trace juga, cuma saya nak terangkan takut you belum faham. So Y dengan X, so Y minus 1 kat bawah kan. Y tukar kat ni. Okay, kat bawah ni. So mana garisan tu dekat 3D? Dia dekat bawah ni, kat tepi ni kan. Betul?
Ni garisan apa? Ni garisan yang doktor tengah tunjuk ni garisan Y equal to negative 1 kan?
Y equal to minus. Betul lah, ni negatif 1 kat bawah kan? Ini kalau dia punya trace Y negatif 1 kan kat bawah. So sekarang ni you convert to 3D. You convert to 3D. Mana garisan yang biru ni dekat sini? So dia dekat sini lah kan? Cuba awak pusing sikit kepala nanti awak nampak.
Okay.
Lepas tu you buat projection. Projection tu maknanya you kena tarikkan dia lah. Tarikkan dia ke mana. Kalau you kata you nak tengok dia pada Z, you nak tengok pada Z, you tarikkan dia ke atas. Maknanya you punya projection lain, you dapatlah bentuk macam tu.
Faham.
Nampak sebab saya nak terangkan ni tadi guna trace guna takut belum faham lagi kan. So tak apa, baru satu contoh kan, nanti kita buat banyak contoh.
Okay, sebab macam faham sekarang tapi takut nanti buat soalan lain, takut tak nak buat. Tapi next week doktor akan terangkan, kita akan buat lagi kan contoh macam ni.
Banyak, ini baru satu example. Banyak lagi.
Okay, thank you doktor.
Okay, welcome. Exercise attendance malam. Okay. Nanti saya share jawapan dia dekat group Saya akan share, cuma saya lupa nak upload. Yang mana yang awak nak tanya? Domain dengan range ke? Biar tu ada Wia. Okay. You nak tanya domain range ya? Domain range. Yang apa soalan dia? Boleh tak awak turn on you punya mic? Ke ada masalah dengan mic? Okay. Apa soalan ni?
Buat construction.
Sorry?
5 belakang rumah buat construction.
Oh, I see.
5 tolak X kuasa 2 tolak Y kuasa 2.
Oh, okay. So nak cari domain. So ni Z lah kan? Okay. So domain. Okay, domain, kalau domain sekarang ni dia bukan log, dia bukan fraction form, dia bukan square root. So maknanya dia ni sebenarnya bolehlah pilih apa-apa. Dia tak ada masalah lah supaya Z tu nanti akan sentiasa ada nombor. Faham tak maksudnya? Now awak tanya dalam hati. Okay, boleh tak letak apa-apa X? Akan ada masalah tak dengan Z? Tak ada masalah kan? So then Y pula. Sebab sekarang ni X dengan Y dia term berbeza. Dia bukan dalam satu family. Maknanya you boleh tengok satu-satu. So maksudnya Y pula ada masalah. Tak ada kan? So maksudnya domain apa-apa je lah.
Cuma untuk range tu kita ada restriction
Ya, betul. Kalau range tu nilai Z kan? Sekarang kita cakap nilai Z. Okay? Sekarang nilai Z, satu yang saya pesan sebelum ni, tengok dalam awak punya expression tu, ada tak yang very constant yang stand alone? Yang dia seorang-seorang je. Dia bukannya dah sama dengan S. Adakah 5? So maknanya mesti akan ada interval untuk Z tu. Sebab ada 5 ni. Kalau saya buang 5, still adalah juga sebab negatif kan. So jawapan Z sentiasa negatif kan. Sentiasa negatif which is sentiasa lebih kecil dan sama dengan kosong. So itu mesti interval. Tapi sebab sekarang ni ada 5, so mesti nombor tu akan ada kaitan. Nombor 5 ni akan ada kaitan. Jadi macam mana nak tengok? Macam saya ada bagi contoh sebelum ni. Apa yang boleh kita buat? Awak boleh factorize dulu. Jadi macam tu kan? Okay, lepas tu awak tanyalah dalam hati, what is the possible value dalam bracket ni?
Any value.
Itu nilai X dengan Y. You can put any value. Itu domain. Itu domain. Okay, you can put. Tapi apa result dia? As a whole.
Positive number.
Sentiasa positif. So, bila you kata sentiasa positif, maknanya kita cuba list kan. What is the possible? So, 0, 1, 10, kalau tak 100 ke. Okay, so kita tengok sekarang. So, kalau sekarang kita nak tengok, kalau kita letak kosong dalam bracket tu, what is the value of Z? So, 5 tolak kosong. Dapat 5. Lepas tu, kalau nilai dalam bracket tu 1, so Z sama dengan 5 tolak 1 dapat 4. Teruskan lagi lah. So, kalau you nampak pattern dia, tak apalah. So, kalau you letak 100, letak 1000, akan ada masalah tak dekat nilai Z? Tak ada kan?
Jadi negatif.
5 tolak 100. Kalau 1000, 5 tolak 1000 ke sejuta ke, maksudnya nilai dia makin lama makin kecil kan? Ini negatif apa ni? 95. Ni negatif apa ni? 99. 995. So makin lama makin kecil. Tapi dia tak ada boundary. Dia makin lama makin kecil, sangat-sangat kecil. Tapi dia tak ada boundary. So kesimpulannya, nilai Z tu adalah sentiasa lebih kecil dan sama dengan 5. Itulah cara nak tengok.
Kiranya 5 tu dia punya max value lah, max boundary.
Betul. So inilah jadi dia punya interval you kena letak, constraint you kena letak dalam range tu.
Doktor, kalau contohnya kita ada function 1 over. Kan dia punya untuk domain kan not equal to 0.
Betul. Contohnya ni.
So range dia pun ikut sekali ya doktor? Not equal to 0.
Sebab yelah, contohnya macam awak kata kat sini, dia tidak boleh jadi kosong. Sebab kalau jadi kosong, nombor dia jadi does not exist kan?
Betul.
Jadi Z tu pun tidak boleh lah. Tidak akan ada kosong lah. Sebab kosong tu tak wujud dalam kes ni. Dalam kes ni kosong tu tak wujud. Maksudnya Z sama kosong tu tak ada. Tak wujud. Sebabnya kita dah setkan dalam domain tadi, tak akan ada yang hasil bawah dia sama dengan kosong. Jadi memang tak akan wujud lah. Jadi Z tidak akan sama dengan kosong. Tu range dia.
Understood. Doktor, yang untuk Z tu yang bawah tu, jadi graf dia boleh jadi any point lah kan doktor? Kita sketch kat semua graf lah kan?
Maksud awak domain ke?
Domain.
Betul. Dia jadi macam ni lah awak sketch tu. Macam ni je. Sebab apa-apa je. Pada awak explain.
Terima kasih doktor.
Sama. Okay saya salam. Ada yang tanya soalan lagi ke? Ke saya leave Okay.